Welcome back to brand new video on design and simulation of basic CMOS inverter in Xschem. So without wasting any time, let's start the video. Okay, first right click on the desktop and open the terminal. Create a directory by typing mkdir followed by your directory name. In this example, I will name it inverter. Now open the directory, right click in the directory and select open in terminal to access it in the terminal. Okay, to launch the Xschem software, type Xschem and press enter. If Xschem and other open source tools are not installed, click on the I button for the installation instructions. Now create a new tab by pressing the plus icon. To close a tab, right click on it and select close tab. To save a file, click on new and save or press Ctrl S to open the save dialog box. Save the file in the directory you created earlier and name it as inv.sch. Note that .sch extension is necessary. Now click OK to confirm. Now we got a blank canvas. Now we need to place the components, or we called as a symbols. So to do so, press Shift I to open the choose symbol dialog box. Locate the pfet and nfet symbols from Skywater130 PDK by navigating to the Sky130 FDPR directory. Scroll to find and select the components or use the search box. Repeat the same steps to add the nfet transistor. Now we have placed the pfet and nfet. Now we need to connect them together to form an inverter. Okay. To connect the components with the wires, place the cursor on the terminal of a pfet. Then press W to start drawing and press W again to change direction. Move the cursor to the destination and left click to complete the connection. Now to fit the schematic in view, press F to zoom fit the schematic. Now we need to add terminals for our inverter. So to add the terminals, press Shift I and select the symbols from the Xschem library. We need to select I pin for input and O pin for the output. For now, select I pin for the input such as VDD, A and ground. Now to copy the symbol, select the symbol and press C to copy the symbol and place them appropriately. For the output pin, select O pin from the library. Rename the pins by double clicking on them and assigning proper names. Connect the body terminal of pfet to VDD and the body terminal of the nfet to ground. Now save the schematic. Now we are done with the schematic. Now we need to convert the schematic into a symbol to use it for the simulation purpose. To do so, press A on the keyboard and click OK. The symbol will be created in the directory with the same name as the schematic. Now open a new tab to create the inverter test bench using the created symbol. To insert the symbol which we have created, press Shift I, navigate to the current directory and select the inverter symbol. Place it on the canvas. To simulate the inverter, we need to add power source by pressing Shift I and searching for V source from the Xschem library. Place two sources on the canvas and copy one as needed. Add the ground symbol and connect it to the source and inverter. Use lab pins to connect sources to the inverter without wires, keeping the test bench clean and organized. Ensure the lab pins have identical names for virtual connection. Assign values to the sources by double-clicking on the symbols to open their properties. For the inverter, provide a pulse input using ngSpice format. We need to provide the value as follows. For the VDD source, set the value to 1.8. To help Xschem recognize the symbols, add the corner TT file from the Skywater130 PDK directory. To specify the simulation type and duration by selecting the code shown symbol from the Xschem library. Place it on the canvas, open its properties and enter the required details. Save the file. Now, we need to generate the netlist. To generate it, we need to click on the netlist. If no error pop-up appears, your test bench is ready. Click Simulate to run the simulation. To plot waveforms, type plot followed by the net name, such as plot A for the input waveform, plot V out for the output waveform. Or plot A V out to display both the waveforms in the same window.